Hortonworks provides a sandbox environment that we can use as a data source within SAP Lumira to explore big data. In this example, we'll download the sandbox from the Hortonworks website and configure it for use with SAP Lumira. If we have not already logged in or registered for an account, we'll be prompted to do so. Otherwise, the download will start automatically. The sandbox is several gigabytes, so it may take some time to download. Once the download is complete, we'll move the file out of the Downloads folder to a permanent location. Once the file is in its permanent location, the sandbox needs to be imported as a new virtual machine into the directory of our desired virtualization tool, in this case, VMware Player. It takes several minutes to import the sandbox. Once it's imported, we need to make a few changes to the settings. First, in this example, we need to adjust the memory allocated to the virtual machine so that it has enough memory to start and run all of its services, but not so much that it starves the host machine of its resources. In this example, we'll set the memory to 4096 megabytes. And second, we need to change the network adapter to bridged, which allows our host machine and the virtual machine to communicate with each other and with the internet. Now we can start the image. A startup script runs in the image, starting the underlying services. Once the script is complete, a unique IP address is generated for the sandbox. We can exit the image, but leave it running in the background, and navigate to the IP address to launch the Hortonworks sandbox. By default, the website opens to the About page. Note that the Hive HCatalog version is 1.2.1, and we're logged in as the username Hugh. Now that the sandbox is running, the next step is to set up our data. In this example, we'll build a table for on-time flight statistics based on a CSV file with a large quantity of data. First, we'll create a new directory and import the source spreadsheets into the file browser. The spreadsheets here were downloaded from the website for the United States Department of Transportation, Bureau of Transportation Statistics at www.transstats.bts.gov. The main spreadsheet contains the downloaded columns from the database for on-time performance, while the other files are lookup tables for airlines, cancellation reasons, and days of the week. We'll load the main spreadsheet only. Note that the size of this file is not representative of the size of data sources Hadoop is capable of handling. It's for demonstration purposes only. Note that the file has been uploaded to the directory. Next, we'll switch to the Hive query editor and create a temporary table to hold the data from the CSV file. In the query editor, we can use HiveQL syntax to construct statements to create and populate the temporary table. This query creates a table called temp_flights. The table contains one column called call_value with a data type of string. Now we'll take a quick look at the table we just created. Note that the table contains one column and no data. Next, we'll populate the temporary table. This query loads the data from the main CSV file, identified by name and location in the file browser, and overwrites any data that may exist in the temporary table. Now we'll take a quick look at the data in the temporary table. Note that the contents of the CSV file have been loaded into the single column in the table. When a file is used to create a table, the file itself is consumed in the process. We'll take a quick look in the file browser to confirm. The file is no longer available. The next step is to create a table with individual columns for the data we want, into which we can parse the comma-separated values from the temporary table. This query creates a new table with columns for each of the columns in the original file. Now we'll review the table we just created. The table contains the columns defined in the query, but no data. Now that the table has been created, we can parse the data from the temporary table and load it into the new table. The rge_exp_extract command lets us parse pieces of data out of the string of comma-separated values in the temporary table. The syntax defines where the breaks happen and in which column to place the extracted value. We'll check the final results for the table. Now that the sandbox contains our data, we can acquire the dataset and create some visualizations. This connection type supports Apache Hadoop Hive and Cloudera Impala JDBC database access drivers. We'll use the default Apache driver and enter our connection information. The host is the unique IP address generated when we started the image, while the port number for this installation is 10,000. The username is Hugh. The left pane displays all of the available tables. No SQL is required, we just need to select our table. We can choose whether we will sample our data and specify how much of the entire dataset we want to use for our initial exploration. This lets us work on a smaller dataset locally to define the task required to cleanse the data and gain insights using a manageable number of records. These data transformations can then be applied to the full Hadoop cluster. Now we'll check the sample data and then acquire the dataset. A sample dataset is generated for the table. Note that this is where we can choose to generate the full dataset once we're satisfied with our data cleansing and visualization activities. We'll save the document before we go any further. We can make simple changes to the dataset, such as converting dimensions to measures and vice versa. For example, in this dataset, the numeric airline ID and flight number columns have been turned into measures, although they're not actually relevant. However, some features are not available because of the size of the dataset. For example, we're unable to create calculated measures and dimensions or generate hierarchies. For this type of dataset, we can only merge it with other Hadoop datasets. However, we can blend the data between this and other non-Hadoop datasets. In this example, we'll create a visualization to show the total number of cancellations in our dataset, broken down by cancellation code and description. We need to acquire the lookup table that provides a description of the cancellation codes in our main dataset. Once the lookup table is acquired, we can join it to the main dataset using the cancellation code column. We'll also add the description of the type of cancellation and adjust the chart to display the additional information. Note that we can now see the number of cancellations in our sample, broken down by type. To apply the same transformations and visualizations to the full dataset, we need to submit a job to Oozie, which is configured as part of the sandbox and which can be managed within SAP Lumira. Keep in mind that if the dataset is very large, there may be too many data points to render in certain chart types, so it may be necessary to apply filters to key visualizations before generating the full dataset. First, we'll specify a name for our new document. Next, we need to define the settings for Oozie. In this example, the server for each of these settings is the IP address for the sandbox, although these services can be running on different machines in a full Hadoop implementation. The Oozie Hive site XML may not exist on the sandbox. If necessary, we can log into the command prompt generated when we started the virtual machine using the root, Hadoop username and password, change to the HDFS account, make a new directory, and copy the file into our new directory using the following code. There are also some jar files that may not be available, which we can copy into the appropriate directory using the following code. Now we need to set up the web HDFS server in our preferences. As with the other servers, this is the IP address for our sandbox. Note that we need to add a new value in our host file that maps the IP address to the machine name sandbox.hortonworks.com to enable communication between the machines. The port is 50070, the user is HDFS, and the output directory is /Lumira documents/. Note that the HDFS output directory must also exist in the virtual machine. If necessary, using the command prompt, we can create the directory and assign read-write access to all users using the following code. Now we can generate the full dataset. Now that the job has been scheduled, we can close the current document and check the status of the job in Oozie. Note that the file is running. Once the job is complete, we can access the new document from here and see how the data transformations from our sample have been applied to the full dataset. The new document displays the same visualization, now with the larger numbers associated with the full dataset. For more details on how to prepare data, build visualizations, compose stories, and share content with other users, refer to the full list of SAP Lumira tutorials on the SCN. Visit the SAP Store to download SAP Lumira free today.